Okay, well, nice to meet all of y'all. My name is Jeff McCormick from Crunchy Data. We're going to present today on some of our container technologies, in particular running on Kubernetes distributions with our Crunchy Postgres. I'm the director of container technologies there. I spend a lot of my time doing development on these products, so after the presentation, if you have detailed questions or something, we can go into much more detail. So here's what we're going to cover in the next 20, 30 minutes. I'm going to give you an overview of our technologies, how they work on Kubernetes in particular, and some of the architecture behind these things and what they provide for businesses. I'm also going to go into a technical roadmap for these products to give you an idea of where they're going technically and how those features might be useful to you in your enterprise. So Crunchy Data is a Postgres company with a heavy security focus, and some of the security certifications are listed there. In particular, security certifications for government and federal are listed there, and that's really important to our customers to have different kinds of security certification. And Crunchy is a developer of Postgres and has several committers working with the company, so we're very active in promoting Postgres through different security certifications like EA or Common Criteria and CIS are some examples. We also are a cloud-ready provider of Postgres, so this is open source Postgres, and my job in particular has been to cloud-enable Postgres and make it where it's easy to run, easy to deploy in a cloud-native way on technologies like Kubernetes. It's also something that's open source. You can run it on-premise. You can also run it on environments like GKE, which if I have time at the end of this, I'll demonstrate this working on a GKE instance. Also runs on things like PKS as long as you have a Kubernetes certified release of Kubernetes, this should run on it. And I think to date we have it running on 3 or 4 different Kubernetes platforms, both in the cloud and on-premise. We're a leader in Postgres, we believe. We're the largest committer to Postgres from an open source community perspective. And it's definitely where our company is focused. We're just a Postgres company, and we specifically deal with open source Postgres. So what is Crunchy Postgres for Kubernetes? We started this project about 4 years ago, actively targeting things like Kubernetes. We have a project called Crunchy Container Suite, which is a set of microservices, all Docker container images today. I think there's like 14 of these. They're all focused around automating and managing and running Postgres from a container perspective. And then the next project we did after that is a high-level orchestration project called the Crunchy Postgres Operator. And this project really makes use of the microservices, and it wires things together for you. So it's more of an end-user solution that's ready to go if you want to build or deploy a database as a service. It's definitely actively developed within our company. We have a team that's dedicated to working on it, and you can see our work out there on GitHub as well. And we've had some really good success, I would say, in the last 12 months in particular with the operator and large-scale companies who internally want to develop a database as a service capability around Postgres. So they're able to use this operator to rapidly make that happen within their companies. So we're in Fortune 100 and some very large government installations. So what is these microservices, this Crunchy Container Suite? This is kind of a busy chart, but it shows all of the different, kind of like you can think of these as Lego blocks. Each one is a container, and they do different things for you, like The most basic fundamental thing is containerizing Postgres itself, but then on top of that is administration functions, backup functions. It's really turned into kind of a robust, we think, set of microservices all around running and executing Postgres. And this works in Kubernetes as well as just standalone Docker too. We support different versions of Postgres. In particular, we have a PostGIS container that is based off of our Postgres container, and that's very popular for geospatial apps. We do 9.5, 9.6, and 10.x simultaneously. So as Postgres does patches and security fixes on all of those major versions, we do re-release all of our containers based on that. So in-house, because we're actively committing to the Postgres project, we time our container releases in conjunction with Postgres releases. Customers like that a lot, and we also build the source code ourselves for customers that really want to know the provenance of who has actually built their binaries for Postgres. So we offer the containerized version of that, as well as just what you grab off the open source community repos as well. But we do things like high availability, disaster recovery, monitoring. We offer multiple kinds of backup solutions for Postgres, things that a DBA managing Postgres would typically look for. And we target other kind of high profile or popular Postgres technologies, and we'll containerize those and add them into this microservice container suite. So we treat those as Lego building blocks, as things that you can wire together to build solutions for your customers. It's all open source as well. That's a kind of a fundamental thing about our company, is what we produce is open source, and you can grab it off of GitHub. The GitHub site's listed there below. We ship three things. I always tell my developers, we ship working code or images based off that code, but we also ship examples of how to use it and documentation as well. So I would say we spend half our time just on making sure the documentation and examples are as good as we can make them, and hopefully it makes for a more consumable product. So we do spend a lot of time on those things. We do releases also, just an FYI, about every 6 to 7 weeks we'll do usually a release. So if you're trying to deploy these containers, we found early on that you get up to a point where you deploy like 50 of these containers, and one person can kind of manage that the way they've traditionally managed it. But whenever you start talking about hundreds of containers or even thousands of database containers, we kind of put together a little chart here to demonstrate that at one point of the number of things that you're actually deploying, the cost of managing that gets really heavy on you if you try to manage it kind of in a traditional form. So we started looking at how we could automate the management of large databases as a service deployments. And that's really where this operator came about, is to try to solve that problem. We routinely go into customers now that want to deploy literally 500 to 1,000 databases in their database as a service environment. One place that we're talking to now is upwards of 2,500. So these are very large companies. They want to do Postgres as a service across their enterprise, and they want to do this on Kubernetes, and it translates literally into thousands of these containers. So that's really where the operator is trying to solve and help aid that problem. So a little bit, some of the highlights about the operator. Open source again. It's all baked or built directly against the Kubernetes API. So it's wired directly into your kube cluster, and it can talk at the API level. And that's how it gets its power and can do some of the more advanced features. This is all Golang code that we've written against the Kubernetes API. So when you deploy the operator into your kube cluster like PKS, it's sitting there running in one namespace. It's per namespace. And it's taking user requests and turning those into Kubernetes requests. So you might give it a request to say, I need a 3-node Postgres cluster. And it'll take that and break that down into n numbers of Kubernetes low-level resources. It'll deploy those, and it'll also auto-wire and configure those Kubernetes resources together. So that saves you a lot of time in terms of managing deployments of sophisticated Postgres clusters. There's a REST API to this as well. Unlike a lot of operators that don't have really a human interface to them, we thought from day one that DBAs in particular and integrators at large enterprises needed a way to interact with this operator. So there's a REST API we built into it, and you can use our command line client to interact with this tool, or you could actually write your own if you can do REST development. The goal here is to assist DBAs with day 2 operations and DevOps people. So provisioning a bunch of containers is really not a big deal. It's what comes after that we really spend a lot of our time focusing on, and also focusing on very complicated, we think enterprise or real world deployments of Postgres, where you're not typically just deploying a single Postgres primary, but you're doing primaries with some number of replicas, and you're managing failover, backups, and things of that nature. So that's what this project's really trying to accomplish. It is based on those lower level Lego blocks. So when it wants to create Postgres containers or perform backups, what it's actually doing is delegating and using that lower level set of microservices to do its job. You as consumers could write your own solutions with those lower level microservices. Nothing would prevent you from doing that. But we do think the operators gives you a lot of predefined patterns and tooling around it so that it eliminates a lot of manual scripting that you have to do, or debugging of things that you normally would have to do if you try to build this thing on your own. The link at the bottom is the Github repo site as well. So this is under heavy development. We push out our new release about every 6 to 8 weeks on this too. And it also follows the pattern of when Postgres does a release, we do an updated release of this project as well. The containers are out on Docker Hub. If you want to try this out, you could actually pull this down and try it for nothing as well. We also build internal versions of this for customers that, again, are more based on us building the actual packaging. And some customers really demand that, as opposed to containers based off of RPMs or packages built by somebody else. So we have an open source free version totally you can pull off Docker Hub. And then we also have an internal set of containers that we provide to enterprise customers as well. So the operator is really geared towards an administrator of databases. And the goal here long term is that a DBA really shouldn't have to know Kubernetes to work with this. With a lot of different container technologies, you'll see DBAs and end users having to break into Kubernetes, run kube control commands to do anything. And we're really trying to not make that the case with this Postgres operator, but gear it much more towards an end DBA so that they can just sit down, run the DBA type of commands that they want to do, and they don't have to be logged into your Kubernetes system. And we think from a security posture, that's definitely where big enterprises want to be. They don't want to be giving out kube control access to their entire, staff. So the goal with this project really also is to let people, enterprises, build a database as a service. And in this case, it's Postgres as a service. So we find a lot of customers have groups within their company that are really, their mission is to supply, provision databases ready to go for projects or groups as they get stood up. So this really tries to aid that project. This is a little bit about the architecture of it, the different pieces of this. And I could go into a lot of detail here, but at the end of the day, the operator is just Kubernetes objects and resources that get deployed into your kube environment. They start up, and then they're basically sitting there waiting for you to interact with it. So it's not out doing things that you're not telling it to do. You would tell it things like, hey, I need 3 Postgres databases created. And the operator will get that request. And basically through these components here, it'll make that happen. One interesting thing is with that REST API, we're able to bridge from PCF over to things like PKS through that REST API. And we actually have a component that hooks into here. And what's interesting about that component is you can run these CF create commands and actually go through this operator bridge, or it's an open service broker implementation, and it delegates down to the Postgres operator to create and provision databases and expose those back to your PCF applications. And that's really a recent thing we've done, but it's getting a lot of attention for people that are currently running PCF but want to bridge over to databases on PKS, for example. We're working on a user interface too, a web-based user interface. I'll show you the command line in a minute, but everybody wants a web-based interface, so we're working on that heavily. And that uses the same REST API. And we think that's kind of going to be another tool for people that just have to have a web-based interface. We'll give you a starting point basically for a web-based interface. Today we've written that with like React.js. So that's work in progress. I don't have it ready to demo today. It's kind of pre-alpha, but that's where we're going with this. You'll have a command line tool and you'll have a web-based tool that'll do functionally the same things. So what happens whenever you interact with this? Typically you say, I want to create a database. And here's actually what happens is all of these objects here represent Kubernetes resources. And the operator basically orchestrates the build out of all of those components for you. Everything with a dashed line is optional too. So you have the ability as a database administrator to say, give me a database that looks like this with these characteristics, and the operator will take that and turn that into actual Kubernetes resource request. And it's talking to Kubernetes basically on your behalf. So this can get really sophisticated, like with 1 primary and 2 replicas, which is a very typical realistic production Postgres deployment. So in that case, you have all of these objects. So when I say you could wire all this together with the microservices, you certainly could do that, but it kind of can get error prone and it doesn't give you a lot of customization either. So that's what we're trying to solve as well. So some of the people that have used this are large government groups that, again, are in the thousands of databases. These are people that run on-premise mostly, have their own data centers. They manage their own storage. So for them, they drop this into their kube environment. And internally, they set up roles and that basically allow people to provision their own databases. And that's really powerful change for a lot of these companies, is when you push the provisioning process down to like your DBAs. So when you make these requests to the operator, you're actually provisioning storage as well as the compute. So a lot of power is getting pushed down and flexibility in terms of what gets created by people. So large government organizations really like that because they want to go to a more self-service model. And that's also the case, though, with Fortune 100. We've had a lot of success this year with the operator at very large commercial companies that essentially are all going to a database as a service, and Postgres is is really on their short list of databases. All of them want to do the same thing. They want to reduce the amount of time it takes to provision databases for their app teams. And with the operator, it's kind of a few seconds operation to provision. And with the security controls we have in place here too, we allow companies to basically configure the operator from a security perspective so that you can very fine-grained control who can do what in terms of provisioning things on your PKS system, for example. One production database, example I always say is one production database at some of these companies turns into like 300 development versions of that database. And that's really the power here is with something like this, you can automate the provisioning for like a 300-person team in a matter of minutes. Even though you might have one target production system, if you look at test, QA, dev, there's this gigantic explosion of copies of databases. And these are just totally prime targets for technology like this, in that you can essentially containerize that whole raft of inventory that you normally would have to spend more time on doing. So we see a lot of big companies, even though they may not even run this in production, all that dev test QA goes to Kubernetes, and with an operator they can just auto provision and auto manage the whole thing. And I think that's really powerful with some of these companies that have thousands of employees, thousands of database applications. That's where you get the real benefit is on that kind of scale with a tool like this. Some of the things we're going to do with this technology going in the next, I'd say, 8 months, and it's kind of my job to set that technology direction. So I get a lot of feedback from shows like this. Customers, prospects come up to me usually and say, well, that's pretty cool, but it would be more awesome if you did this one feature. So we're heavily geared towards listening to real use cases, and that drives our product direction really large. Some of the things we're doing, and what we just did was the Open Service Broker implementation. That again provides a bridge from PCF over to PKS, for example. And we think that's really useful for some customer environments. We're going to do a web-based user interface just because people expect that and want that and have demanded that. PG Backrest is a large-scale backup product that Crunchy actually is driving from an open source perspective. So if you have, like, say, terabyte size or above Postgres databases, we're integrating Backrest so that you can do incremental and differential backups on those large data sets, and that product is getting integrated in as well. Backup management is a problem that we're addressing, or are going to attempt to address soon too, because if you have 1,000 databases and you want to do backups on some routine basis, you have this gigantic explosion of backups that you need to manage. And we're going to address that so that you can apply metadata to the number of backups you do, and then you can do mass archives against the metadata filtering and powerful things like that. Some of the other things on here that are kind of interesting and big are like the next to last two things. It says Ingress. So what that's going to do is allow you to basically allow networking Kubernetes ingress routes to be built and provisioned as part of the operator's functionality. And some large-scale enterprises want that as well. And that gives you a lot of control over ingress into your Postgres database, essentially. And then lastly there, or next to last, is today the operator runs in one namespace on your kube cluster. People want operators to be federated across disparate Kubernetes clusters. And that's something we're actively working on. The notion there is you could use an alternate kube cluster for like a disaster recovery site and have the operator just mirror everything from one side over to another. This is the web user interface I was talking about. There's not a lot to see yet, but the idea here is everything I'm going to show you on a command line you'll be able to do through the web interface. And it's going to work with very much a search engine kind of capability here so that you can give it metadata tags and do filtering based on the metadata that you apply. And overall, that's a real big concept in the operator. It allows you as kind of end users to apply your own metadata to everything that's deployed. So you're able to do commands against that metadata. And it's very powerful if you're talking about thousands of containers or databases you have to manage. So we make heavy use of Kubernetes metadata in order to accomplish that. So if this is sort of interesting to you, there's way more we could do in terms of talking to you about this. I think we routinely do over, when we go out to places and really talk about this, we can spend half a day just going over this technology. There's people listed here. If you have any interest in follow-ups, we can do much deeper dives than we have occasion to do in a venue like this. But we think it provides a lot of value for big enterprises wanting to do Postgres as a service on Kubernetes platforms. We think it's a good platform for people. There's a bunch of links to the open source projects. That's another great resource. That'll give you a good idea. This slide deck I know they're going to make available too. So if you have any information, the GitHub's a very good resource. And then some of the names on there, Robert Bates and Paul Lawrence, for example, look up their email addresses, and we're happy to talk with bigger enterprises. Let me try to do a demo real quick. I think I have 3 minutes. So I don't know if you can see that screen, but basically I'm running the operator on a GKE instance. So if I do kubectl get nodes, it's a 3-node cluster, basically I stood up. I've applied metadata to those nodes like server type equals fast. So things you can do with this operator is you can say PGO create cluster demo fast. So that one command is kind of interesting. By passing in a flag node label server type equals fast, I've just told Kubernetes that I want you to schedule this Postgres cluster, which is a 1-node cluster called demo fast. When you go to schedule that, I want you to look for nodes that have a matching node label. So by default, if I take node label off, Kubernetes scheduler will just deploy it anywhere, right? So we've baked in what they call Kubernetes node affinity into this operator, and it enables you to basically target different pieces of your Postgres cluster to specific kinds of nodes. And you can apply those node labels any way you want. Those can be fast, slow, expensive, cheap, on fire, nearly on fire, whatever you want to do. And it's the kind of flexibility, though, to pin certain pieces of your Postgres clusters onto certain kinds of kube nodes that big customers push that feature into this product. We also have similar things with storage. This product, you can pass a command flag and specify that you want your Postgres primary to be on this storage type, and I want my replicas to be on a completely different storage type. So when you design your Kubernetes storage architecture, you could say set up a DR storage type, and with this operator, you can define that DR storage type and say, I want my backup today to run to the DR storage type. And that's some of the kind of the enterprise features. And I think I've got like 40 seconds left, so I didn't get to show you much. But if you do things like, that's just a simple ping on it, and it'll actually give you the IP addresses of the database just to prove it's working. So now if I wanted to, this one's running inside my kube cluster, I can pass flags to this as well to expose it using a load balancer service type. And that actually will expose that Postgres container out to outbound traffic. So I could actually get into it. If I had more than 10 seconds, I would show you that. But it's an interesting project. The command line tool runs on Mac, Windows, and Linux. So it's really easy for people like y'all to try it out. And I think I'm out of time. Appreciate y'all. Thank you.